Welcome to True Projects. In this video, we are going to explain about a project titled Human Atlas Protein Classification. The project's primary focus is on classifying the human protein using the Human Atlas dataset, which contain images from the train and test folders. Machine learning algorithms, specifically the decision tree deep learning algorithm, convolutional neural network are employed to train the model and assess their performance in terms of accuracy, precision, recall, and other evaluation metrics. The project encompasses of different modules and the comparison of results is depicted through a graph highlighting the accuracy disparity between the decision tree and the CNN algorithms. The objective of this project is to create a protein classification system by employing the machine learning and the deep learning algorithm. Through the training of decision tree and convolutional neural network model using the Human Atlas dataset, the objective is to achieve the accurate classification of human proteins. The project evaluates the performance of both algorithms in terms of accuracy, precision, and recall into the effectiveness of each approach for protein classification. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first one is upload Human Atlas dataset. Using this module, we will upload the Human Atlas dataset to the application. And the second module is pre-process the dataset. Using this module, we will read and train the images and then resize all the images to the equal size, shuffle and normalize the images. And the third module is train decision tree algorithm. Using this module, we will train the decision tree algorithm on the training dataset and then test its performance using the test images. And the fourth module is train CNN algorithm. Using this module, we will train the CNN algorithm on the training dataset and then test its performance using the test images. And the fifth module is human protein classification. Using this module, we will input the test image and then the model will classify its protein atlas. And the final module is comparison graph. Using this module, we will plot the accuracy comparison graph between the both algorithms. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder consisting of test and train folders, consisting of the 4 different folders, consist of different images within it. And the model folder consisting of H5 files and NPY files which contain the algorithm information. These files will be loaded at the time of execution of the project. And the test images folder consisting of the various images which is used for testing the model, and the Human Atlas classification and test train or the Python files, and run is a bat file. Instead of executing the program in command line interface, we created a Windows bat file to execute the project. Now to run the project, double click on run.bat file. Here, this is the graphical user interface. With this, we are interacting with the program. Now click on Upload Human Atlas dataset and select the dataset and click on Select Folder button. Here we get screen of dataset is loaded and contain of 4 classes within the dataset, that are eosinophil, lymphocyte, monocyte and neutrophil. And click on Pre-Process Dataset button. Here the dataset is pre-processed and we get a sample image to display in purpose whether the dataset is loaded correctly or not, and close this image. Here the dataset is pre-processed and divided into training and testing part, where training is used in 9957 and testing 2487. And click on Train Decision Tree Algorithm button. By this, the decision tree algorithm model is generated on the pre-processed dataset. Here we get a confusion matrix where x-axis represents of the predictor label and the y-axis represents of true label, and the count with the same label in x and y-axis represent the correct prediction and the other boxes represents the incorrect prediction count. And also we can see the raw graph X-axis represents the false positive rate and the Y-axis represents of true positive rate. And if the blue line comes below the orange line, then prediction is false. And if that comes on top of the orange line, then the prediction is true. And close this graph. And here we can see the accuracy of decision tree is 27, precision 27, recall 27 and export to 27%. And click on try and CNN algorithm button. By this, the CNN model is generated where use of confusion matrix and ROC curve where x-axis represents a predictor label and y-axis represents of true label, and the count within the same label in x and y-axis represents the correct prediction count. And in the ROC graph, we can see that of x-axis represents a false positive rate and the y-axis represents of true positive rate. And then close this one. And here we can see of accuracy is precision and recall F1 score of CNN gives of 97%, and click on human protein classification button. By this, we redirect it to the test image folder and select any one of the image from this test images, and I'm selecting the third image and click on open button. Here by this we can recognize as of this image is of neutrophil, and close this. In this way, we can classify the human protein by using the CNN model and decision tree model, and click on comparison graph button. By this, we can see of x-axis represents the algorithms we used and the y-axis represents the value assigned for the each metric. And here, blue bar represents of accuracy, orange bar represents of F1 score, green bar represents of precision, and red bar represents of recall. In conclusion, this project successfully developed a protein classification system using machine learning and deep learning algorithm. The decision tree and convolutional neural network models were trained and evaluated on the human atlas dataset. The results showed that CNN model outperformed the decision tree algorithm, achieving the higher accuracy and precision in protein classification. This project highlights the potential of deep learning technique in accurately classifying the human proteins, contributing to advancement in biomedical research and drug discovery.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.